Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain numerical application that is in chemical kinetics. And this is introduction part 4 where I am going to explain the first order reaction in inversion of cane sugar. Inversion of cane sugar, which is a first order reaction, but here the dextrorotatory, levorotatory both are used in inversion reaction, and that is why according to polarimeter you know the rotation value, change of rotation. So inversion of cane sugar is a pseudo first order reaction. Remember, this is also one pseudo first order reaction, just like hydrolysis of ethyl acetate. And here remember, this is very important, it is an optically active compound, that is dextrorotatory. So here dextro and levio, they both plus and minus signs are used, change of rotation occurs, and here this is called inversion of cane sugar. And after hydrolysis, one is levio-fructose, other one is glucose, that is dextrose plus 1. So dextro plus and levio minus, that is glucose and fructose. So what is the reactant here? That is sucrose, C12H22O11, which is positive dextro. On hydrolysis, that is a pseudo first reaction, that is why here you can say the water which is present in large amount, so in presence of acid also, and here you will see the product are glucose D and fructose minus L or levio, dextro plus. And here what you will observe in what are the reading you will observe? The reading at time t 0. That means when the commencement of reaction not started, the reaction is not started, that is called time equal to 0, and rotation value, that is R0. Remember, from here you will see what will the formula for the inversion of cane sugar as a first order reaction. Reading at time t, when you see time 0, that is R0. When reading at time t, that is RT. So reading at infinite time, that is, what is infinite time? If the reaction occurs 24 hours or more than 24 hours, then only here you will observe what is the infinite reading. Infinite reading means time equal to infinity. So the rotation, how we will write? R infinity. So infinity time is after 24 hours. What is infinity time? You will say it is after 24 hours. If for 1 hour and that there is no infinite time is required as R infinity, but when the time that is after 24 hours, the t equal to infinity, and the rotation that is known as R infinity. So initial concentration of sucrose, that is A, small a, how can you say R0 minus R infinity? Because the reaction when it is time 0, the values are 0. So what is initial concentration of sucrose? That is R0 minus R infinity. Similarly, decrease in concentration after time t. What amount is used? What amount is consumed or it is undergoing reaction? That is X. Then what is that value then? R0 minus RT. When it is infinity, you can say R0 minus R infinity. When after time t, that is X equal to R0 minus R infinity. Remember, it is clear. I think it is clear to you. So here it is the X value this one and A value this one. Then concentration of sucrose at any time t. Concentration of sucrose at any time t, that is A minus X. That is, or you can know and remember from the first order, you remember A by A minus X. So here what is the result then? A minus X equal to, here you take the value A and take the value X and subtract both. That means R0 minus R infinity, and here it is minus R0 by RT, minus RT. Again see, this is the A value, R0 minus R infinity, minus X value, R0 minus RT. So what is the result then? You make a minus, that result is RT minus R infinity. What is the value of this one? A minus X. What is the value of A? R0 minus R infinity. See, remember, this is R A value and A minus value this one. So you put the value, simple. K equal to 2.303 T log A by A minus X. This is the first order rate equation where you can calculate easily K. But since here rotation in polarimeter it is observed, that is why R0 minus R infinity, and then it is equal to R0 minus R infinity divided by RT minus R infinity. That means here you can say, again remember, this is A value, this is what value? A. This is what value? A minus X. So here R0 minus R infinity, see here, this is the A. This is the A. And here RT minus R infinity, this is the A minus X value. A minus X value means this is one RT minus R infinity. So it is easy now. And here remember, the derivation is not so much required, only formula you should remember, and the value in the question, numerical question, all values are given except 1. So if you want to calculate K, T is given, R0 at time T, R infinity at infinity time, similarly RT the time at time T, value, a rotation value at time T. So all values should be given by which you can calculate the either rate constant or time T. So what is the general expression for the rate equation of an nth order? You know, 0 order, first order, second order in I think in introduction part 1, and here part 1 and part 2 also. When you read properly from part 1 to part 3, you will find all the values, 0, first order and second, third order. So if you find the general expression for the nth order, then what is the meaning? So minus d R molar concentration by dt, that is instant value, that is equal to rate also. And here also from the rate law we know K, the molar concentration R to the power n. Remember here this one. So what happened here? What is the n value? N may or may not equal. So what is the value then? If you equating both, K equal to, for n order, if you say for n value on integrating, the value comes to 1 by, this is the very complicated formula, but try to remember, and here you will get the general expression for the n order. So then come to general expression for time taken of n order, generally just A by A minus x. Remember, A the initial concentration and A minus x, that is the left behind concentration of the reactant which are left behind, and x is used or consumed or reacting. So these are the moles. So what is the answer then? T equal to 2.303 by K log A by A minus x. To calculate for nth fraction, then you should write what is x. X equal to A. What is x? X equal to A by n. So this is the value where you can calculate the nth fraction. Reaction of first order, and here nth fraction. So what is the value? Put the value x equal to A by n and calculate. See, T 1 by n fraction, and here 2.303 by K log A by A minus x. So you should put the value of x. And what is the answer here? Log A by A minus A by n. So what is the value? And after simplifying, this value comes to 2.303 log n by n minus 1. The value of n should be given, or all values should be there, and you will find n also. So according to question, you will put the values and get the answer. So T, very important one, T 1 by n, this is equal to 2.303 by K log n by n minus 1. This formula is very important for fractional value. Then how can you calculate units of rate constant? You know rate constant means K. How can you calculate? And you also know rate. What is rate? Change of concentration. What is rate? You know before also. And change of concentration by time. What is the units of concentration? Molar concentration. That is moles per liter. Or you can write mole L minus 1 if you are calculating that unit. That is why you will put properly and divided by S. Remember, time is S and concentration this one. So concentration this value and time is this value. Then what happened? This is the answer. Mole L minus 1, S minus 1. This is the actually rate value that is here comes to. But when you calculate units of rate constant, rate is calculated, rate is there. Then you will put then what is the rate, and according to law of mass action or rate law. Rate equal to, see, the rate equal to here K concentration of reactant to the power n. What is mean to the power n? N may be 0, this n. The n may be 0, so n may be 0 or 1 or 2, etc. So here you can find n may be 0, n may be 1, n may be 2, n may be 3. Okay. So if 0, then first order, 0 order. If it is 1, first order. If it is 2, and then it is third order. Sorry, if 2 it is second order. If it is 3, third order. So here you will see 0 first or here second. Remember, second or here third. So according to that you can know, but how can you calculate the unit of rate constant? That means there are two rate value. One is rate equal to concentration by time, and the unit comes to moles L minus S minus. And here if you say rate equal to K concentration, now what happened? You will make equal both. This is the first equation. This is equation 1 and this is equation 2. Then what to do? You will make equal both. Then you will get the answer of K. So here K equal to rate 1 by concentration N, because you will take this rate this side Then what happened? See again. See, the rate equal to this much, K concentration to the power n, then K equal to 1 by rate. So if you say K equal to, if you take concentration to the power n, and here what a value? K equal to rate into, instead of concentration to the power n, you will write 1 by concentration to the power n. Say what is the, after calculation, what is the value? You know what is rate? Rate is concentration by time. So you know rate equal concentration by time, and here this value put. Then again simplify this one. This is the concentration, nothing mean 1, and time mean, here put time or only put time first, but after that you will put second, and here into the concentration to the power n. If you take concentration this side, then what happened? 1 by time into 1 by concentration n minus 1. Is it clear? Concentration n minus 1. The units of rate constant. So this is the formula, remember. If you easily want, then this is the formula. K equal to 1 by T, concentration n by minus 1. If, how can you derive for zero order? Same. This is the general one, before that I told. But now we will see, this is the, this is the zero order. So, you know, zero order mean K equal to, here K equal to, So, units for rate constant for zero order, rate equal to K a to the power 0. According to mathematics, anything power to 0, 1, so rate equal to K. You put rate value, that is moles per liter second. Per liter, moles per liter divided by second, and it is K. So K equal to simply moles L minus L inverse second inverse, or you can say K equal to mole L minus 1 and S minus 1. So this is the zero order. Similarly for the first order, what happened? Rate equal to K a to the power 1. You know this one according to rate law. And if you say moles per liter divided by second and equal to K moles per liter, then both sides it will cancel, and what is remaining? K equal to second inverse, okay, or second minus 1. Better you say this is the second inverse. What is the? This is for first order. So remember, for first order, the unit of K, that is second inverse. Units of rate constant for second order, what to do? Again you put the value according to rate law. Rate equal to K a to the power square. What is A? A you actually you should write R, otherwise it will confuse. So you put R. R is the what? Reactant. So here what happened? The that is concentration of reactant to the power, here to the power 2. So moles per liter to the power 2. And this side rate mean moles L minus or L inverse by divided by S. Both sides will cancel each other. Here one part, here two part times. So one time cancel, and what is the answer? K equal to 1 by mole L inverse S. If you say you go to up denominator, then what happened here? 1 by mole L inverse second. So what is K value? So L, that changes to L minus changes to L, mole, that is changes to mole inverse, second it changes to second inverse. So what happened here? K equal to liter mole inverse second inverse. Similarly, third order mean rate equal to K a to the power 3. Are you clear? Rate equal to K a to the power 3. That means it is the third order reaction. If third order reaction, this side you put more rate, that is moles per liter per second, and this side also. So right side you can say K moles per liter to the power 3. So both side, left side is 1 time moles per liter, and right side moles per liter 3 times. So after cancelling, then what you will get? K equal to, here K equal to 1 by mole square L minus 2 S. Similarly, here mole changes to minus 2, L changes to here 2 only, and S changes to S minus 1. So what is the answer? L square mole inverse 2 second inverse 1. This is the answer for third order. Remember, this is the third order. So how many orders you know till now? 0 order, first order, second order, third order. So most important, 0 and first order. If it is in the form of gas, then what are the units of rate constant? 0 order, moles per liter. Instead of moles per liter, you will write ATM, atmosphere. S inverse. First order, S inverse, same time, but instead of moles per liter, you will write here atom. So second order reaction, here this is ATM inverse, second inverse. Third order, similarly ATM minus 2, S minus 1, and then what is the nth order? Remember, for third order it is minus 2, meaning 1 less. Third order and it is minus 2. Similarly, nth order, it should be 1 minus n, and second inverse. Are you clear? That means for the pressure, where the atmosphere word is used, where the pressure is used for the gas phase reaction, where it is 0 order, it is first order. And if you say, if it is 0 order, generally first order, and some examples you read, if it is 0 order, these are the atom, second inverse, first order, second inverse, second order, atmosphere minus 1, second minus 1. Similarly, we will follow up to nth order. So here, I hope it is clear to you. First, for gas phase reaction, here you will follow that. You will follow that polarimeter. If it is inversion of cane sugar, it is also first order. But here you will observe rotation. Rotation, one is R0, RT, R infinity. After 24 hours, if the reaction proceeds, this is R infinity. If at a particular time, that is RT, and if the before starting, that is R0. According to that, you will follow the reaction, first order, and after that you will see what are the unit constant for different order, 0 order, first, second, third, like this. And here all are very useful for the numerical application in chemical kinetics. For the coming video, we will see different type of numerical problems.